213.113 Defective rails. A. When an owner of track to which the part applies is learned through the inspection, otherwise the railway contains the defect listed in the following table. Person designated under Statute 213.7 shall determine whether or not the track may continue in use and determine whether the track may continue or operation over the defective rail is not permitted until the rail is replaced. Remedial action prescribed in the table is initiated. All right, your rail defect remedial action table: length of defect, percent of the railway crossing area, section weekend, and defective replace and not replace. Transverse fissure, compound fissure, detailed fracture, engine burn fracture, defective weld, horizontal split head, split web pipe rail, head web separation, butthole crack, broken base, ordinary brake, damaged rail, flattened rail. No, as a person designated under Statute 213.7, the visually supervise each of the operation over the defective rail. A2, assign an in-person designated under Statute 213.7 to make a visual inspection. After the visual inspection, the person may authorize the operation to continue without continuous visual supervision, maximum of 10 miles an hour for a 24-hour prior to another such visual inspection for the replacement of the repair and of the rail. Limiting over the speed of over the defective rail authorized by a person designated under Statute 213.7a who has at least 1 year of supervisor experience in railroad track maintenance. The operating speed cannot be over 30 miles an hour. The maximum allowable speed of under 213.9 for the class tracking concern, whichever is lower. C. Apply joint bars bolted on to get through outermost holes defective within 20 days after it is determined whether continuing the track and the use in case of the Class 3 through 5 track, limiting operating speed over the defective rail to 30 miles an hour. Unit joint bars are applied, therefore, limiting speed to 50 miles an hour, maximum allowable speed under the 213.9 for the class of the track concerned, whichever is lower. When a search internal rail defects is conducted with the Statute 213.2237, defects is discovered in Class 3 and 5 with the requirement that remedial action. C. The operating speed shall be limited to 50 miles an hour, maximum allowable speed under 213.9 for the class of or track that concern, whichever is lower, for the period of not exceeding 4 days. The defective rail has not been removed from the track. Permanent repair made within 4 days of the discovery. The limited operating speed over the defective rail is 30 miles an hour until the joint bars are applied. Thereafter, the limited speed limit of 50 miles an hour for the maximum allowable speed under the 239 for the class track concern, whichever is lower. D. Apply joint bars only through the outermost hole of the defective 10 days after determined to continue with the track of the use. In the case of the Class 3 through 5 track, limited operating speed over the defective rail is to 30 miles an hour, less authorized by the person designated under Statute 213.7a, who has at least 1 year supervisory experience in the railroad track maintenance under the joint bars acquired thereafter. Limited their speed to 50 miles an hour, maximum allowable speed under 213N with the class track concerned, whichever is lower. E. Apply joint bar to defective bolt in accordance with the Statute 213.121 D and E. Inspect the 90-day rails, and if it is determined to continue the track and use. G. Inspection of the rails 30 days after determined to continue in the track and use. H. Limiting operating speed over the defective rail to 50 miles an hour or the maximum allowable speed under the Statute 239.9. Class of track considered 213.9 of the class of track concerned, whichever is lower, limiting operating speed of the defective rail to 30 miles an hour or maximum allowable speed under Statute 213.9 for the class track concerned, whichever is lower. Alright, as used in this section, the transverse fissure means the progressive crosswise fracture starting with the crystalline center of the nucleus inside of the head, for which it spreads out with a smooth and bright and broad dark round over the surface, sustaining a right angle with the length of the rail, distinguishing the feature of the transverse fissure over the type of the fracture, the defects of the crystalline center of the nucleus, nearly smooth face, or development of surrounds it. Compound fissure means the progressive fracture originating in horizontal spread of the turns up and down and head of the rail, as in smooth and bright darkening sight, or if it's progressing obtain until substantially at a right angle with the length of the rail, compounded with the fissures, require examination of both face and fracture to locate the horizontal split head from which they originate. Alright, 3. Horizontal split means the horizontal progressive deflective origination inside the railhead, usually a quarter inch or more below the running split, or if it's progressively horizontally in all directions and generally accompanied by the flat spot of the running surface. The defective appears with the crack lengthwise of the railway, which reaches the side of the railhead. Vertical split head means a vertical split through or near the middle of the head, extending it into the line throughout it. A crack or rusty streak may show under the head of the close of the web, and pieces may be split on the side of the head. 5. A split web means the lengthwise crossing, crack along the side of the web and extending through it. And 6. A pipe rail means a vertical split and usually web due to the failure of shrinking cavity ingot unity in rolling. Broken base is any break in the base of the rail. Detailed fracture means a progressive fracture originating at or near the surface of the railhead. These fractures should not be confused with the transverse fissure, compound fissures, other defects which are internal origins. Detailed fractures may arise from the shell spots ahead of the checking and flaking. 9. Engine burn fracture means a progressive fracture originating with the spot driving wheels and having slipped on the top of the railhead in developing downward, frequently resembling the compound even transverse fissures, which shall not be confused or classified. 10. Ordinary break between partial and complete in which there is no sign of the fissure, in which no other defects described in the paragraph are found. 11. Damaged rail means any broken, injured wrecks, broken, flattened, unbalanced wheels, slipping, or similar causes. 12 is a flattened rail means a short length of not jointed which has the flat across the width of the railhead of the depth of 3/8 inch or more below the rest of the rail. Flattened rail occurrences have no repetitive regulatory that does not include corrugations that have no apparent localized cause with such a welding engine burn. The individual length of relatively short compared in the conditions such as a head and flow of low rail curves. Alright, 13 is a bolt crack, meaning the cracks across the web originating from the bolt hole progressing from the path either include upward toward railhead, inclined downward toward base. Fully developed bolt hole cracks may continue horizontally along the head web and the base web fillet and may progress into and through ahead of the base and separated with the piece of the rail end of the joint rail and multiple cracks occurring from the one end of the rail. And considering a single defect, however, the bolt hole occurring with the adjacent rail ends within the same joint must be reported in the same separate defects. 14. A defective weld means a field or paint plant weld containing any discontinuities or pockets exceeding 5% of the railhead area, the individual 10% of the aggregated originated near the transverse plane due to incomplete penetration of the welded metal between the rail ends, the lack of fusion between the weld and rail end metal. Entrainment and the slag and sand underbed of the shrinking, cracking, fatigue, cracking, weld defects may be originated with the railhead, web base, and same cases cracks may progress the defective into either or both of the joining rail ends. 15. Head and web separation means the progressive fracture longitudinally separating the head from the web of the rail at the head fillet area. Alright, your guidance. Remedial action required for the defective rail specifically define the time limit, the speed. The remedial action also allows certain discretions of the track owner for the continued operation over the certain defects. Inspectors should consider all rail defects dangerous, and care should be taken to determine if the proper remedial action have been accomplished by the railroad. When one or more of the defects is present in the rail, the defects required with the most restrictive remedial action shown shall govern. The remedial action table is the specification rule and address the risks associated with the rail and failure. These risks are primarily dependent upon the defective size, defective type, and size should not be dependent upon the manner of the mechanism reveals the existence of the defect. Failure due to the track owner to comply with the operating speed restriction and maintenance procedures prescribed in the inspection intervals specified in section 213-237. Defective rails inspection of the rail respective may constitute the violation of the traffic safety standards. Note A and A2 addresses a mid-range transverse defective size. The remedial action allows the train to operate with a continuing maximum of 10 miles an hour up to 24 hours following a visual inspection of person designated under statute 213.7. If the rail is not replaced under 24 hours, the cycle begins. Note B, limits on speed and authorized by the person designated under statute 213.7a who has at least 1 year supervisor experience in the track maintenance. The qualified person has the responsibility to evaluate the rail defect, authorized maximum operating speed over the defective rail base over the side of the defective operating conditions. However, the maximum speed over the rail may not exceed 30 miles an hour. Maximum speed under statute 239 for the class of the track considered, whichever is lower. Note C, D, and H, limit of the operating speed following the application of the joint bars 50 miles per hour. The maximum allowable speed under statute 213.9 with the class track concerned, whichever is lower. The maximum speed is note in the B, C, D, and H if they exceed with the current track speed of the railroad is required to require the defect. For example, the railroad determines the remedial action B is required with the track speed already in 30 miles an hour or less. The railroad must record the defect, indicate the railroad is aware of the characteristic of the defect rail and has designated a permissible speed in compliance with the regulation. When the FRA inspector does not discover a defective rail that requires the railroad representative to determine whether to continue the track and use of designated maximum speed over the rail, the inspector should inquire the representative's knowledge of the defect of the remedial action. If the railroad is not aware of the defect prior to the FRA inspection should observe the actions taken by the railroad representative to determine the compliance. If the railroad previously found the defective rail, the inspector should confirm that the proper remedial action was taken. During the record inspection, the FRA inspector should confirm the defects recorded and remedial actions were taken. The remedial action table of defects failing with the transverse plane, the transverse and the compound fissures, detailed engine burn fractures, defective weld, special air limit, lower limited range base is of 5% of the railhead cross-sectional area. The transverse defective is reported to be less than 5%. The track owner is not eligible to provide corrective action under the track safety standards. Defects reported less than 5% are not consistently found during the rail break routines, and therefore defect termination within his range is not always reliable. Transverse and compound fissure defects weaken between 5 to 70% of the cross-sectional head area. The remedial action node B defects the range of the set between 70 to 100% of the cross-sectional head area. Require the remedial action note A2 as prescribed in defective effective 100% of the cross-sectional area of the head. Require the remedial action at note A is prescribed the most restrictive. Inspectors should be aware that the transverse compound fissures are defective in the failure to the transverse plane and are characteristic of the rail that has not been controlled, cooled, normally rolled in prior in 1936. Defects intended to group the detail fracture, the engine burn fracture, defect welds will weaken, also failure to transverse plane. The detail factors characteristic of the controlled cooled area, usually indicated with the letters the CC and CH, rail brand, and the rail brand. These prescribed the remedial action relates to low range page between 5 to 25%, mid range 25 to 80% for note C and D, respectively. The defects require join bars, application, operation, speed restrictions, certain time or frames. The defective extending less than 180%, requiring visual inspection. If the rail is not replaced effectively and repaired and removed from the source, electively would be respective operation to maximum 10 miles per hour for the use of 24 hours to then perform another visual inspection. The second sentence of the remedial action notice addressed the defects was discovered in the Class 3 and 5 during the initial rail inspection required under Statute 213-237, determined not to be excessive to 25% of the railhead cross-section area. For those specific defects, the track owner may operate the period not to exceed 4 days at a speed limit of 550 miles per hour, with a maximum allowable speed under Statute 213-9 for the class of the track concerned, whichever is lower. If the defect is not removed or permanently, the repair is not made within 4 days. The discovered speed limit is 30 miles an hour until the joint bars are applied and the rail is replaced. The requirements specified in the second paragraph are intended to promote the better utilization of rail inspection equipment, therefore maximizing the opportunity to discover all the defects which approach the surface the failure's size. The result of the FRA research indicates the defective type of the size, the range, and predictable slow growth life. The research forth and indicated that even the most heavily utilized track in the use of today, defects type and the size are unlikely to grow surface and failure, so that is in 4 days. The remedial action table of longitudinal defects are combined with one group of subjects with identical remedial action based on their report size. These type of longitudinal defects share similar growth rates and the same remedial actions as are appropriate to each of the type. Defective rail categorized by the horizontal split head, vertical split head, split web pipe rail, head web separation, or longitudinal in nature. When any of the group of defects is more than 1 inch, but not more than 2 inches, the remedial action initiated under the note H is limited the train to speed of 50 miles an hour. Note that F requires the reinspection of the rails in 90 days. If in deciding on the operation will continue the defect in the range of more than 2 inches, but not more than 4 inches, requiring complying with not what's one I and G speed limit of 30 miles an hour, but then rail reinspected in 30 days, they decide the operation will continue. When any of the 5 defectives exceed the limit length of 4 inches, the person designated under the statute 213-7A must limit the operation speeds of 30 miles an hour under the note B. Another form of head web separation, often referred to as the fillet crack railed, is the longitudinal growth of the crack and fillet area, usually the gauge size of the outer of the outer rail of the curve of the crack may not exceed the full width of between the head and the end and the web butt, and the potential dangerous evidence of the fillet in the crack of the hairline cracking and running beneath the head of the rail with the bleeding of the rust discoloration. Fillet of the cracks often result from the improper super elevation form and stress reversal as a result of transposing the rail. The use of them is as a mirror and effective with the aid of the examining of the rail and the determination of the head web's cracks and the separation in the body of the rail. A bolt hole crack is a progressive fracture originating with a bolt extending away from the hole, usually at an angle. Developed with the high stress riser, usually initiating as both a dynamic terminal response with the joint bolt pointing along the edge of the hole underloaded. A major cause of the high stress and improper field drilling of the hole. Excessive longitudinal rail movement that can also cause the high stress along the edge of the hole. While evaluating the rail end, which was multiple bolt hole cracks, inspector will determine the required remedial action based on the length of the longest individual bolt hole crack. Under notes H and F, the remedial action for the bolt hole crack more than 1/2 inch, but not more than 1 inch. If the rail is not replaced and is limited to a speed of 50 miles an hour or the maximum allowed under Statute 213.9 for the class of the track concerned, whichever is lower, then re-inspect the rail in 90 days if an operation will continue. For the bolt hole cracks greater than 1 inch but not exceeding 1 and 1/2 inches, the notes H and G apply. The rails are required to be limited with 50 miles an hour, re-inspected within 30 days for the bolt hole exceeding 1 1/2 inches. Person qualified under statute 213.7a may elect to designate a speed restriction which cannot be exceed 30 miles an hour with the maximum allowable under statute 213.9 for the class track concerned, whichever is lower. Under notes F and G, where corrective action requires rail to be re-inspected with a specific number of days after the discovery, several options of the compliance may be exercised depending on the nature of the defect. For those defects which are strictly internal and are not visible to the naked eye, the only option would be to perform another inspection with the rail flaw detection equipment, either rail mounted or handheld. For the defectives that are visible with the naked eye, therefore, the measurable visual inspection or inspection of the rail flaw detection equipment are acceptable options. For certain defects enclosed with the joint bar with the areas such as the bolt hole cracks or head web separation of the joint bars must be removed, and if visual and re-inspection is to be made. Re-inspection prescribed in notes F and G must be performed prior to the expiration of the 30-90-day intervals where the rail remains in track and is not replaced for the re-inspection cycle starts openly, which excessive in re-inspection unless the re-inspection reveals that the rail defect to have increased in size, then has therefore become subject to the more restrictive remedial action. This process continues identifying until the rail is removed from the track. Where the corrective action requires the rail to be re-inspected within a specific number of days and discovered, the track owner may exercise several options for the compliance. One option would be to perform another inspection with the raw flaw identification equipment, either the raw mounted or handheld. Another option would be to perform a visual inspection, either with the defect is visible and measurable. In lateral case, for the certain defects that enclosed with the joint bar are as such as the bolt hole breaks, the removal of the joint bar will necessarily comply with the re-inspection requirements, and if the defects remain and the track beyond the re-inspection travel, the railroad must continue to monitor the defects and take the appropriate actions as required in the remedial action table. A broken base result from the improper bearing of the base of the track of the spike and the tie plate shoulders from over the cribbled anchors and may originate with the manufacturing flaw. With today's higher axle loads, the inspector can anticipate the broken base defect in 75-pound and in smaller rail sections with an irregular track surface, especially on the field side. For any of the broken but it is discovered that it's more than 1 inch but less than 6 inches in length. The remedial action note D is to apply all joint bars bolted through the outermost holes defective within 9 to 10 days. If the operations will continue class 3 and 5 track, the operating speed must be reduced to 30 miles an hour or less, but is authorized by a person under the statute 213.7a until the joint bars are applied after the operating speed is limited to 50 miles an hour over the maximum allowable under statute 213.9 for the class track concerned, whichever is lower. Under note D, there are several acceptable outermost holes bolts arrangements for the joint bars centered on the rail defect. See Figure 17 for illustration of acceptable bolting arrangement. In all cases, the railroad may not drill a bolt hole and next to a defect that is being remedial with the application of the joint bars pursuant to note D. The reason is not drilling next to the defect is preventing the propagation of the crack into the hole closest to the defect. Figure 17 shows the bolt and no bolt hole in the rail. A broken base is in excess of 6 inches requires an assignment of the person designated under the statute 213.7 to visually supervise each of the train operating over the defective rail. The railroad may apply the joints to defective bolt then in accordance with the statute 213.120 DE. The railroad may apply joint bar to defective bolt and then in accordance with the statute 213-121D and E, and thereafter the may must limit the train operation 30 miles an hour or the maximum allowable under 213.9 for the outermost class track, concerning whichever is lower, is reference the dimension between the outermost hole and 24-inch joint bar varying between approximately 15 to 18 inches. 13-16-inch joint bars approach to 30 inches. Inspectors should point out the track of the owner of the broken bases nearing these dimensions and may negotiate the purpose of the joint bars applied. The broken base of the rail may be caused by the damaged external sources such as the rail anchors in being driven through the base of the derailed wheel. It is improper to consider that damaged rail as defective of the address more than stringent provisions applicable to broken base rails under the note A through A and E and I. Damaged rail can result from the flat and broken wheels and indicated with the hammer blows and derail with the dragging equipment, reducing the operating speed in the class 3 through 5 tracking 30 miles an hour until the joint bars are applied, lessening the impact force imparted onto the weakening air. Applying the joint bars under the note D ensures the proper horizontal vertical rail end alignment in the event of the rail flaws. Alright, flattened rails. Localized capillaps have head rail. Are also caused by mechanical interaction from the repetitive wheel load. The FRA industry and the researchers indicate that these occurrences are more accurately categorized as rail surface conditions, not rail defects, as they do not themselves cause service failure of the rail. Although it is not a condition shown to affect the structural integrity of the rail section, it can result less than desirable dynamic vehicle response within higher speed ranges. The flattened rail condition is identified in the table as well as the definition portion of statute 213-113B as being 3/8 of an inch or more in depth below the rest of the railhead and 8 inches or more in length. The defect becomes more severe by a reduced railhead depth, wheel force increase. The rule addresses the flattened rail in terms of specified remedial action for those in certain depth lengths. The location meeting the depth and the length of the criteria shall be limited to an operating speed of 50 miles an hour with the maximum allowable under statute 213.9 for the class of the track concerning whichever is lower. Alright, breakout and railhead is defined in the piece of the physical separated with the parent with the rail, and the rail defects meeting the definition is required to have in each of the operation over the defective rail visually supervised by the person designated under statute 213.7. The inspector needs to be aware that the definition is applicability across the wide range of rail defects as indicated with the remedial action table where the rail defects have been not progressed to the point where they meet the definition of a breakout, but due to the type of the length and the location of the defect, they present a hazard to contain the train operation. Inspector should determine what remedial actions, if and any, track owner should institute. The following are two-headed rail head brake two-head brake out examples where a corrective action would be necessary. Example 1. There is a bolt hole break in the head with the rail is totally separated with the parent rail and either too tight or loose, but the piece of the rail was not physically lifted off the joint bars by hand. The inspectors may be determined that the separation was totally by the fact that the separated pieces rattled when tapped. It's important that the railroad take an appropriate remedial action in this situation because it is potentially very unsafe. It's important to know what will happen when the next train operates over this defect. The train could cause the piece and become so loose that it comes out of place and cocks at an angle and causes the wheel to ramp up. Example 2 is a vertical split head defect of the rail where the vehicle head separation is apparent because the inspector can determine if the physical separation has been occurred through the railhead, but the railhead is not entirely separated over the entire length of the defect. The issue of excessive rail wear continues to be evaluated the Rail Integrity Task Force. The FRA believes that insufficient data exists at the time the indicated with the parameters for the condition shall be proposed at the minimum standard. The Sperry Rail Service prints the excellent reference manuals on the rail defects. Inspectors are expected to convert rail defects, appearances, growth, and hazards and methods of defection. Some railroads apply the safety welded straps to the thermite type of the field welds. These straps do not provide the same support of the joint bar. They would provide not only the limited support if the weld would break and under the train movement and such that they do not comply with under the provision of the corrective action C, D, and E installation of a joint bar. Only joint bars will be full contact with the bottom of the railhead at the rail base. Section 213-121A. With the manufacturer relief of the welded material will comply with the corrective actions C and D and E. When the FRA inspector finds the rail defect that appears to originate with the fatigue at a bond wire attachment weld, the inspector should cite the railroad with the defective code of 213 with 1316. Inspector must also identify the narrative type of the railroad defect and defective weld, defective detail fracture, etc. The FRA has added the defective code based on the National Transportation Safety Board recommendation arising from the National Transportation Safety Board investigation of February 9, 2003. Canadian National Derailment Temora, Illinois. The National Transportation Safety Board determined the probable cause of the accident was the Canadian National placement of the bond of the wired welds on the head of the rail just outside the joint bars where interpreted Martin say associated with the welds and less fatigue cracking that because of the increased stressing associated with known soft ballast conditions rapidly progressed to a rail failure. All right, 213, 115 rail and mismatch.